Hey there guys, this is just a quick review of how to draw Lewis dot structures, which is what we've learned the past couple of days in class. So when we're drawing a Lewis dot structure, the first thing we need to do is we need to figure out, is it going to be for something that's ionic, which means we're going to transfer electrons, or is it going to be something that's covalent, where we're going to share electrons. That's important because if we're ionic or covalent is going to dictate what our picture looks like. If we're ionic, we have to see that we have positive and negative ions that are attracted to each other because the electrons are transferred. If we're covalent, we need to see that the electrons are shared in those covalent bonds. So how you figure out if you're ionic or covalent is ionics are going to be made with a metal and a nonmetal. Where covalent is going to be nonmetals only. So if we look at these examples here, sodium is in the first column, which tells us it's a metal, so this guy is going to be ionic. P and O are both nonmetals, so this guy's going to be covalent. And C and O are both nonmetals, so this guy's going to be covalent. So let's go ahead and let's do our ionic picture first. If you think back to the day where we did ionic notes, when you're drawing the Lewis dot for an ionic compound, what you do first is you draw each individual atom and then you show how the electrons are transferred. So this 2 tells me that I've got 2 sodiums, so I'm going to start my picture by writing my 2 sodium atoms. I look at my periodic table and figure out what column they're in. They're both in column 1, which means they get 1 valence electron. Then I'm going to draw my O. My O is in column 6, so that means it's going to get 6 dots. So remember, we have to put 1 on each side before we pair, so I'm going to do 1, 2, 3, 4, 5, 6. So in an ionic thing, we have our electrons being transferred. So my first sodium is going to lose an electron to here. My second sodium is going to lose an electron to here. So my 2 sodium atoms both no longer have any electrons, and because they both lost 1 electron, they have a +1 charge. My oxygen is going to have the 6 electrons it started with, plus the 2 electrons it gained from the sodium to make it octet happy. And so that's how it fills its shell. I put it in brackets and I put a -2 charge on the outside because it took in 2 electrons. And then this would be my final answer. I've shown that the electrons are transferred from the sodium to the oxygen to become octet happy. These lose 1 electron, which is why they're +1. And this O gains 2 electrons, which is why it's -2. So this would be my final answer for my Lewis dot structure. When we're doing covalent bonds, because they're sharing electrons, we're going to see lines in our picture like we saw in class yesterday. So I'm going to go ahead and I'm going to do 2 different examples. We learned 2 ways. We learned the picture method and the math method. So I'm going to do PO4 by using the picture method, and I'm going to do CO2 by using the math method. Now remember, I don't care which method you choose, just as long as you use one. I personally feel that the picture method is easier 80% of the time, and the math method is useful about 20% of the time. You may find that you only like the picture method or you only like the math method. It doesn't really matter to me. I just want you guys to be able to draw these things so we can use them later in class. So how you draw the picture method for a covalent compound is it starts very similar to the ionic one. The element that comes first is what goes in the middle. So my P is going to go in the middle of my picture, and then I'm going to put my 4 O's around it. And then you give each each atom the amount of dots that they get from the periodic table. So we know the O's are in column 6, so they're all going to get 6 dots. And then my P is in column 5, so he's going to get 5 dots. So if you think back to the rules we talked about yesterday, you can only play connect the dots with things that aren't paired up already. So this guy's not paired up and that guy's not paired up, so I can play connect the dots. this guy's not paired up, and this guy's not paired up, so I can play connect the dots. And this guy's not paired up, and this guy's not paired up, so I can play connect the dots. I can't break up things that are already found in pairs, so I can only play connect the dots between things that are not paired. Now, if we think about my P right now, he's happy with 8 electrons, 2, 4, 6, 8. But right now, these O's aren't happy. They all have 7, which means they want 1 more electron. This negative charge, remember, tells me that this picture has gained 3 extra electrons. So what I can do is I can put those in my picture using triangles. And if we think about it, if I need to put 3 electrons in, and these 3 atoms are only 1 electron away from being happy, I can put my extra electron on each of those atoms. So now my O has 2, 4, 6, 8 and is happy. This O has 2, 4, 6, 8 and it's happy. And this O has 2, 4, 6, 8 and it's happy. But now we got to deal with this guy here because we need to hook this O into our picture, but the P doesn't want to make any more bonds. This is where that coordinate covalent thing happens. So we're going to go ahead and shift that electron over to this side of the atom, so now they're all paired up. And the phosphorus is going to use these 2 electrons to make a coordinate covalent bond with the oxygen to draw him into the picture. Remember, a coordinate covalent bond is when one atom gives both electrons to the covalent bond. So instead of getting 1 from the oxygen and 1 from the phosphorus, like all these bonds here, in a coordinate covalent bond, this phosphorus gives both its electrons to the oxygen, so the phosphorus remains octet happy, and now the oxygen is octet happy. And because this is a polyatomic ion with a -3 charge, we put it in brackets, and we put a -3 on the outside. So that's the picture method. In the math method, what you do is you count all the valence electrons you have, and you decrease it by the number of bonds you put in each time until all your atoms are happy. So CO2, that means the carbon's going to go in the middle, and the oxygen's going to go on either side. So now we have to count and figure out how many electrons we have to put into our picture. Carbon is in the 4th column, so it brings 4 electrons to the picture. Each oxygen is in the 6th column, so it's going to bring 6 electrons to our picture. So we've got 12 from the oxygens and 4 from the carbons to get us to a total of 16 electrons that we can use. So when we're doing the math method, we're just pretending, hey, these guys have no electrons to start. The whole picture has 16 to put into it, so we're going to add the electrons through putting bonds and lone pairs in. So when you're doing the math method, the first thing you're going to do is you're going to put 1 single bond in between each atom. Remember, our bonds use 2 electrons. So this bond is 2 electrons, and this bond is 2 electrons. So I have used 4 of my 16 electrons. So 16 minus 4 means I have 12 electrons left. So this is where I want to count how many electrons each of these things need and compare it to what I have left. Once those number matches, I'm done. So this guy has 1 bond, so that means my O needs 6 more to be happy. This carbon has 2 bonds, which is 4 electrons total, so he wants 4 more to be happy. And this O has 1 bond, so he's only feeling 2 electrons, so he wants 6 more to be happy. So 6 plus 4 plus 6 means we need 16 more electrons in our picture to make all these guys happy. The 16 that we need does not match the 12 that we have to put in, so this is where we're going to try double bond. So on either side, we can just choose one side. We're going to put 1 double bond. That was 2 more electrons from our total, so we now only have 10 electrons left to use in our picture. But that's going to change these numbers here. Because I've added a bond, these guys now need less electrons. So my oxygen has 2 bonds total, which is 1, 2, 3, 4 electrons. So he only needs 4 more to be happy. My carbon now has 2, 4, 6 electrons, so he only needs 2 more to be happy. So our total electrons that we need to make all our atoms happy is not 16 anymore. It's 6 plus 6, which is 12. These numbers still don't match, so now I need to try another double bond on the other side. So I get another double bond on the other side. That uses 2 more electrons, so I'm down to 8. And now these numbers are going to change. My carbon has 2, 4, 6, 8 total electrons, so he's octet happy. He needs no more. My oxygen over here has 2 4 electrons, so he needs 4 more to be octet happy. 4 plus 4 is 8. Because we have 8 more to put in our picture, and we only need 8 more to make the electrons happy, to make the atoms happy, these numbers match, so we can put lone pairs on our oxygens. Because this oxygen wants 4 more electrons, I'm going to give it those 4 electrons in pairs. Because this atom wants 4 more electrons, I'm going to put it in pairs. And now each atom is octet happy. 2, 4, 6, 8 for this O, 2, 4, 6, 8 for my C, and 2, 4, 6, 8 for this O. And if we count, we'll add up to 16. 2, 4, 6, 8, 10, 12, 14, 16. So we are done, and this is the answer for our Lewis dot structure. I hope you found this helpful. Remember, you can always come in for help before school or shoot me an email if you have further questions.